My voice is a little bit weird. Okay, it's live. Okie dokie. Okay, anything we need to figure out before we start?
No.
Should be good.
You all clear on the stuff? Okay, let's do it. Okay, you're quiet. I mean, Catherine.
Sorry. I was reading the question.
Yeah, no worries. Man, this SPSS thing is so annoying.
Why aren't you using Excel?
Say it again?
Why aren't you using Excel?
Well, why do they keep showing everything in SPSS? All of their examples that use it.
Yeah. Well, I use it in Excel, so which is annoying. and my brain isn't like in its best shape right now. I know I've been sick and I had fever yesterday. Got it done this morning. I just got two classes yet too, just because of this.
Yeah.
Yeah, my brain just not working right now.
It happens.
Yeah. Well, I have you guys, right? Yeah, let's get to it. Oh man. Number 3. What's the value of the test statistics?
I believe it's 0.2.
I got 2 even,
Even.
but I could be wrong.
Okay, there's a bunch of values, but what is the value of the test statistics? That's the problem.
Oh, yeah, I got 2 even.
You got 2 even?
During the second time.
Yeah.
Because it's 2.2 instead of 1.1.
Yep.
Yeah, let's do 2 then. Sorry, my brain is just not working right now. It just sucks.
Oh, that's alright. Mine never does, so.
Being greater than 2 is... Oh my gosh. Okay. Number...
How do you find the p-value if you're just working with these numbers? You put the mean in these boxes?
Sure.
I mean, because you're not working with a whole list of numbers, right?
No, not yet. We don't have that.
I just calculated the other way.
Hi.
Oh man. Click the wrong button, almost erase the whole thing. The probability there. Wait, isn't a p-value the same to probability?
Mm-hmm.
Wait, the probability of being greater than 2 is 0.0403. Alternative hypothesis is not equal to. So it's as extreme as this could be on the same side. So it's just times 2, so it's 0.0403 times 2. Because it's 0.0403 is just one tail, just on the right hand side. You got the same number on the left hand side too. It's not equal to, it's not less than or greater than. Does it make sense?
Can you explain that one more time?
Yeah.
So the probability of greater than 2 is 0.0403, right?
Right.
So this is only on the right hand side. Okay. But our alternative hypothesis is on the other side of the tail. So,
Okay. Yeah. I get that.
0.02.
Will you type that? Because I don't know if you're breaking up for anybody, but I didn't hear
I
any of
didn't
what
get
you
any
just
of it
explained.
either. So
I
would
mean,
the
just
answer be
if you
point?
type the answer, then I can work it backwards and figure out how you got it.
Oh no, it's not. It's not like any calculation. It's just the answer is just right there. It's just time. That's 0.003 times 2. That's the actual p-value.
So it's 0.081.
0.0, yeah,
Wait.
0.081.
Where is 0.081 that you're getting?
Because 0.0403 is on the right hand side of the tail.
Oh, okay. So
And this is a
it's
two-tail
times 2
hypothesis
because
test.
okay, because it's not equal to.
Yes.
Okay, thank you.
That makes more sense.
You said it was 0.081, right?
Well, isn't 0.403 times 2 0.806?
Yeah, 0.806, but round
Yeah, you got a
to
round.
3 decimal places. Make sense?
No, because you're doing 3 decimals, and if you're just multiplying 4. Oh, sorry, I totally missed that second 0. After the decimal, I didn't. Then my mind just deleted that. I've done that twice today. Thank you.
Okay, data file 12 data A. Where the heck is you?
Oh, let's see.
It was 12A yet.
It's right. I mean, if you go into the data file on the where the book is, and you click on the button on the left that says data file, you just go down. It says 12 data A. It's like
12. Oh, it's down there?
yeah, it's chapter 12, so it's in the C section. Data A, and then there's a data
Oh,
B
it's
beside
chapter 12. Okay, gotcha.
it. Okay.
Thank you.
What am I answering?
I'm sure my brain is really not working today. It just sucks.
Question about the differences. Use the
And then
level significance is 10.
Okay, so number 5, I got 31.025.
Are you transferring the data into that other spreadsheet?
Yeah, so the paired sample t-test and the tools that he gave us.
Yeah,
We just took them and put in variable 1 and variable 2.
yeah.
And I took the mean of the differences. I'm not sure if that's right. Pretty sure it is.
D equals sample mean of the differences, yes. D bar.
Let me know what y'all get.
Okay. So, D, um,
What's the question for this one again?
Number 5?
Oh, what is the D bar? Okay.
so 31.025?
Yep, that's what I got.
Okay, yeah.
The heck?
Yeah, that's what I got. 31.125.
So SD is the standard deviation of the differences.
That would just be a number.
31.125.
So that would be 341.157.
Number 5's 341, right?
Yes.
0.157. Okay.
No, that's number 6.
The number 6 is 341.
Yes. Number 5 is 31.025.
Oh, I'm getting mixed up. I was looking at the D and thought it was standard. Okay.
Yeah, the D bar is just the mean of the differences, and the SD is the standard deviation of the differences.
Okay. So it was 31.025,
Yes, for 5.
341.157.
Yes.
Okay.
The test statistic is 0.407, right?
Yes.
Is that what the rest of y'all got too?
Yes.
Yep. Well, I think we'll all get the same answer. Spreadsheet.
Yeah, that's true. And the p-value is 0.689.
Yep.
We failed to reject the null, right?
Huh?
P-value is greater than alpha.
And alpha is 10. Is 0.1. So, yeah.
Just fail to reject the null hypothesis.
We fail to reject. Is that what you said?
Yeah, fail to reject.
Okay, and you reject it when it's low.
Yes.
Okay. So
All right.
number 7, I didn't. How do you solve for number 7? I can't remember
Number
that.
6. Are you on that? Are you on that
That spreadsheet.
that spreadsheet? The second tab at the bottom. You're on the one that's on the differences, correct?
Yes.
Okay. Number 7, they are looking for the p-value. It says,
It's the T.
or the t-value, sorry. It's the one that just says t on the fourth set of boxes on the right.
You got negative 0.118.
No, it's 0.407.
Make sure your type of test is not equal to.
Yeah.
Your n is equal to 20.
There.
Yeah, that does make a difference.
Oh, did
The heck? Why is mine isn't?
in the summary statistics, did you put the mean and the standard deviation in there? 31.025.
Yeah, those are in there.
Let me screen share really quick.
Yeah.
Okay.
Wait, the confidence interval 0.9.
Oh, you know what? You're right. It needs to be 90, not 95 for the confidence.
So I totally forgot to change that one, but
Yeah.
it doesn't change anything, so we're good. It only changes the confidence interval, so we're good.
Oh, okay. All right.
Okay, so what?
You can look at my screen.
Can you click on that box so I can see what your formula is?
This is all given to us.
Yeah, it's all in that spreadsheet. You just have to put the numbers and the variable.
Which spreadsheet you have on, Jordan? There are 3 spreadsheets that he gave us. The one we are using is quantitative interference procedures. Oh, come on!
Let me see. Yeah, I've got the same
As a quantitative
same
invariant
one loaded
procedure.
that Josh has.
Yes. So, did you put in all the variables?
Mm-hmm.
In this case, can be.
How about you show it yours and we'll see what's wrong with it.
Okay. Give me just a sec. That was why. Okay, I was in the one sample T. I just changed it to the paired and that worked.
The second tab at the bottom.
Okay.
All right.
Problem solved. Thanks.
No problem.
So when we switch it to
Greater than, we just basically divided the p-value into half. It still failed to reject.
Okay.
3. Yeah.
Okay, we're gonna do the data B. So data A is useless now. Done.
And I got N is greater.
sorry.
I gotta put all the numbers in first.
What's the competency interval?
N's greater.
So EF. What is that?
N is the sample size, and then that's the freedom. What is it called? The
Degrees of freedom.
degrees of freedom. So
Degrees
that's
of freedom
N
and
minus 1. Yeah.
Okay, alternative hypothesis is not equal to covenant interval is 0.99.
makes the p-value 0.001.
Yep. 0.001. That's reject the messes.
0. Did you say the p-value is 0.001?
Mm-hmm.
Mm-hmm.
Okay. 20. All right. Making sure I do it right.
14 it decreases.
Yeah, of course it decreases. It just cut it in half. Still reject a no. Okay, no hypothesis, you're doomed. Like I am today.
For 14, you got decreases.
Yep. Always decreases when they change to not equal to only a one tail.
Yep.
So either
Oh.
greater than or lesser than is always only half of not equal to.
Okay.
Yep.
See,
And
sure.
so 13 and 15 are reject no.
Okay.
Correct?
Yep, they're both reject.
Alright, just making sure.
P-value depends on how little there is inside and the point to think greater general rule can be made, which alternative hypothesis will give the smallest p-value.
Not enough information, right?
Wait, which alternative hypothesis will give the smallest p-value?
But A and C would get the same p-value, wouldn't it?
Yeah, normally.
Yeah.
I would say what Josh said, not enough info.
Yeah.
But yeah, it's not enough information. Because like you can get if you set the mean to a very high point and you choose a greater than, and it could be like the actual mean could be very, very low.
Mm-hmm.
Oh. Okay.
So like you can never tell.
Yeah. The problem.
Okay, we'll change the confidence interval to 95%.
We're back to this.
Okay. What is the lower bound?
11.914. Correct?
Between for the mean differences. Okay, so we only need the 11 something, like that number, and the lower bound and the upper bound.
Wouldn't it be?
It gives us the answer right there.
11.752.
Huh? What?
Isn't it 5.303?
Yeah, it's just right there. It's a 5.303 and 18.607.
Wait, what are you looking at?
On the bottom set of boxes. The bottom right.
I am looking.
Okay.
Okay. At the okay.
The confidence interval.
All right, because I mine on the confidence interval for some reason I got 11.752.
Did you change your confidence level to 0.95?
0.95? No, I did 5.
That could be why.
That could be why. Oh, look. Hey, those numbers are better.
All right.
5
Jeez,
point.
these are getting longer and longer. 18 questions.
Just more to screw up.
It's getting easier and easier, I feel. I mean, we just have the tools given to us.
Yeah, you just plug in the number and you get everything done. Like, that's basically how real life is. You plug in the number, you don't do a calculation yourself.
True. All right. Are we ready?
Who go first?
Did last time.
We're good.
Okay, we still have a question at the
Mm-hmm.
Right. Yeah, it was just.
thingy, the group collaboration. You guys want to help me out with that because I cannot do it this time.
Sure.
Okay. It's.
It might take me like 3 hours to sort that out. I haven't looked at the question yet though. Meeting.
I'd say this would be sorry, what? Independent.
Well, I can just post a video and then you can just
Yeah.
answer underneath it.
Yeah. But
What?
oh, go ahead. No, it's divided it into two groups.
For a paired data sample,
Yeah, but they're not comparing. You're right. You're not. It's just divided into two groups.
don't you need to get the same people?
Correct. Well, no, not necessarily, because when they had like the dads and the sons, it's two different people, but they're comparing heights for their or the husbands and
Oh,
wives.
we'll just tell if the data should be paired or independent. Okay.
Right.
By an investor house to see if residents of a small town had a good plan for retirement. They broke up the respondents into two categories: people without a college degree and people who had at least a bachelor degree. Each respondent was asked if they had a plan for retirement. The investment house wants to understand if there is a difference between the two education levels regarding having a plan for retirement. Which hypothesis test should they use?
I mean, you have two education levels, and if you have the same amount of responses to
Well,
each,
they
it's
cannot
basic.
they cannot pair them up because the number could never be the same. Like
Okay.
with the pair number with the pair thing, they have to have the group 1 and the group 2 has to be related to group 1, and they also have to be identical in numbers.
Right. Also, I don't know. I mean, the responses, wouldn't it just be yes or no? I'm just wondering, can they even compare yes and no?
Oh no, just have a good plan. They just the retirement. They probably want to do the numbers of like how they invest or and I don't know.
I don't know. Okay.
You don't know how they survey the. So which hypothesis test should they use? It should be there's no difference, and
They
then
want to compare the two groups.
yeah.
Which
So
one has a better plan? People with a bachelor's or people without?
mhm. So differences between the two education levels. Okay, so the alternative hypothesis, so the null hypothesis will be they're the same, and the alternative hypothesis will be they're not the same. My brain hurts.
So we're just
Yeah.
supposed to figure out if it's supposed to be paired or independent.
Yeah.
I think it's independent.
Well, because technically they should be independent because they would not be equal in number, and there's nothing about them that's related.
Mm-hmm. Yeah,
However,
the lesson says matched pairs typically involve only one population.
well, typically, but there's a population like the father and the son, like the examples they gave in the readings. Like it could be if the sons are taller than the fathers, then there are two groups of population they're comparing to, but they're always also related, and they have to be identical in numbers. So
But you're
this
right. I mean,
one,
you got the hypothesis right. It's either they are the
yeah.
same or not.
So Like they are in the same hypothesis test, so they
Right.
are supposed to be dependent, but they could not be dependent at the same time.
Okay.
Hey Josh, what do you think?
I think it's independent.
Yeah.
That's what I thought first. I'm just gonna put independent.
Okay,
Okay.
go for it, Josh.
We all have to put our own answers, though, don't we?
Do we?
I thought everybody was supposed to post on it. That's what it looked at. From what I understood of the email that he had, that everybody was supposed to put an answer.
Email? I did not get an email.
Or it was on the teacher's post board or something.
Oh, really? Okay.
Yeah, there's a couple guys that have already answered just for themselves. So
Okay.
This is weird because the hypothesis because the hypothesis involves both of the party at the same time.
Mm-hmm.
Okay, so the null hypothesis will be the ones with bachelors is equal to the ones without bachelor degrees. And the alternative hypothesis will be those with bachelors is not equal to or greater than those with those without bachelor degrees. So in this term, if they draw samples that are with the same numbers, yeah, the data should be independent.
Yeah,
Okay, let's go with it.
that's pretty much.
I am.
Hey guys, I gotta get going.
Okay,
All
Okay.
right.
See ya.
I'll see you all on Thursday.
yep,
Sounds good. We'll see you then.
bye.
All right. I better go too.
Okay.
So I'll see you guys on Thursday.
Okay.
Okay. Bye.
Bye.
Good night.
See ya.
See ya.